Entering in this into the calculator, if we do 3.69 divided by 1.23, you notice that we get 3. Again, that magical ratio of 3 to 1. So that idea of rate of change should allow us to be able to manipulate the ratio as we need to in order to accompany for the fact that it could be any number of gallons purchased. In some cases, you can't purchase, let's say, a 6-pack of soda is, let's say, $1.99 per 6-pack. Well, it might be tempting. Sorry, I'll just be consistent. Put my units on the right side. $1.99 per 6-pack. Of course, in this case, you can't really say that that means $1.99 divided by 6. You can certainly say that each can costs you 33 cents, but you definitely can't say that you're going to be able to buy one can at a time. So in this case, it's probably not too advisable to try to break this thing down into per one unit. It probably makes more sense to say $1.99 per 6 cans, and then do multiples of 6. In the instance of average rate of change, the difference is that, or we'll call this CRoC, in average rate of change, the rate of change isn't necessarily constant. So in this case, we're talking about iPad unit sales. So this is in thousands. So for example, 18,000 means 18 million iPads sold. And so here we have the number of iPads sold based on the number of, in this case, quarters that have passed by. So June to September is 1 quarter. September to December is 1 quarter. December to March is 1 quarter. So our input units are quarters, and here are 1,000 units sold. Okay, so you can notice already that as the quarters pass on, that there isn't an exact constant rate of increase or decrease in the units sold. So here you can notice that, now this is a bar chart, but they only show bars because sometimes it's inappropriate to show that all of these are connected, since you can't really talk about what happened between June and September. But sometimes we do that in math anyway, where we kind of connect the dots and say, here's sort of what happened, and here's kind of the pattern of what happened. Now you notice that unless this were a straight line, or a straight line downwards or a straight line upwards, we couldn't really say that it has a constant rate of change, right? So we notice that sometimes it goes up, sometimes it goes down, it goes up and down by different amounts. So average rate of change allows us to kind of come up with a ballpark figure of what happened overall. So from, let's say, June to June 2010 to September 2012, let's see what we think happened to the price, to the number of sales. Well, it went from about 3 million, and I'm going to do this in millions. I know the graph is in thousands, but I'm going to do this in millions and just say it went from 3 million sales, and by the time September 2012 had reached, come around, they were only selling, or they were selling 14 million. Now, in this article about iPads, it says that sales are actually down from June 2012 quarter, so they dropped a little bit into September. I'm guessing they probably picked up due to the Christmas sales. So if we look at the rate of change, okay, well, this is our input, and our inputs are in quarters. So let's call June 2010 maybe quarter 0, and then September 2012, well, that's 1, 2, 3, 4, 5, 6, 7, 8, 9 quarters later. So that's the 9th quarter that we're tracking. And so our output, well, what happened to our output? It went up by 11 million. Our input went up by 9 quarters. So what happened here? Well, our rate of change in this case was 11 million iPads per 9 quarters. Right? That's what happened. Now, in reality, we know that it didn't go up by 11 million, or by 11 divided by 9 every month, but if we calculate this, and we say 11 divided by 9, we can say that this is 1.22 million per quarter. So in other words, we just divided and came up with 1.22, telling us, in other words, that 1.22 million